All right, guys, in this video, we are going to talk about variables. Now, when you think of variables, right, you always think of these X and Y's and A's and B's and all that stuff. So there's a good reason why we have variables because variables are kind of a stand-in, a substitution for regular numbers. So if I'm talking about rainfall, the rainfall can be 0 centimeters, or it could be 2.7 centimeters, or it could be like if it's a flood, you're talking about 100 centimeters of rain. So I can say, let X be the amount of rainfall. So instead of calling it with different numbers, I can give it a variable. That's the meaning of a variable. So variable is like a placeholder. Okay, that's where it sits. So you can think of variables as related to geometry like this. This one-dimensional line, you can think of this as a x. This is a two-dimensional shape you have here. That means that it's got a length and a width. You can think of this as a x squared because this 2 here, it represents a length and a width. It says 2D. And when you look at the three-dimensional shape, you can think of this as x to the power of 3 because it's got a length, it's got a width, it's got a height. So that's 3x to the power of 3. So from here, let's move on to define what a term is. So term is an example for a term would be, say, 3x. Now that is a term. That means there are 3 x's in that collection, and that collection is called a term. Or you can have 2x squared. That is a term. Or you can have a very simple number, -7. That can also be a term. You can also have terms that look like this, -x. That is a term. So these are all examples of terms. So when you have examples of terms, there are some things you need to think about. The number in front there, that is called a coefficient. No, that spelling is not right. But anyways, that's a coefficient. Okay, and here, that the x is called a variable. Okay, so the first number is called a coefficient, and this one, the x, is called a variable. In this case, the coefficient is 2, and the variable is x. In this case, if there is no number, what number can we, in this case, the coefficient is -7, and there is no variable here, right? It is just a coefficient only. Here, when there is no number here, we can assume the number to be a 1. So here in this case, the coefficient here, so the coefficient equals -1. Is that clear so far, the numbers? Okay, so we have a coefficient and we have variables. Next task is for us to figure out what are like and unlike terms. Okay, example for like and unlike terms. So example for like terms, which means these terms are similar to each other. So example would be, say, 3 and 4 are like terms. Why? Because they're both numbers. They're just numbers only. In the same way, -7 and 6.1, they are like terms. Also, we can have more examples, say 3x and -4x They can be like terms. Why are they like terms? Because of the x here and the x here. So that is the reason why the x and x, when you have them, they are like terms. So let's write one more example. 2x squared and negative 5x squared, they are also like terms. And why are they like terms? Because x squared here, x squared here. So for like terms, only look at the variable. If the variables are the same, then they are like terms. So one more example for that. If the variables like say 10a and some of the numbers say 1a, they are like terms because both have a in them. That's where they're like terms. And so one more example would be say negative 7b and 2b. They are like terms because both have b's in them. You guys get the idea? Yeah. And let's do example 4, unlike terms. No, this is kind of easier because you know what like terms are. So unlike terms are a lot easier to think about. X and y are not like terms because one is x, the other one is something entirely different, y. X and negative 3x squared, they are also unlike because one of them is a x, the other one is something different, a different beast. Why is it different? Remember, this is like a line. That's like a exponent is different, right? This is like a rectangle or a square. So it's a different variable entirely. So let's write a few more examples for that. Negative 2 and 4x squared. These two are unlike because this one is one of them has a 4x squared here. The other one has got no variable. So they're not like terms either. They're entirely different terms. One more example. So we have 3x squared and 4x, and let's write one more, negative 3. Now there are three of them. None of them are similar or like each other because in the first case it is a square, in the second case it is an x, and in the third case is a negative 3. So basically what you need to know from this lesson is what is a term, number one. Two, in the term there are two bits. There is a coefficient and there is a variable. And once you know that, then you have a bunch of terms. You ask yourself, are these terms like or are these terms unlike? Okay, so how do we use this as an example? So the example we are going to use is, and where is my pen? There we go. The example, group. We are going to group terms. Now, what does that mean? If you have a crate full of apples and oranges, grouping means put all the apples in one, put all the oranges in another crate. So we are going to group similar things together. Okay. So how do we group similar things together? Let's put a bunch of terms here. So let us say I have 3x minus 1 plus x plus 4x minus 10. So we have a bunch of these terms and we put them together, and this is what you call a expression. Okay, it is a expression. All of them is a expression here. So let's underline like terms. There is a 3x here. There is another term that is like it, x here, and there's a third one, 4x, Shall we underline the other like terms? And because they are like terms, right? So here's the beauty of it. Let's do this one. There are 3 apples, 3x. There is 1 apple. 3 apple plus 1 apple gives us 4 apples. Then add another 4 apples to it. So 4 apples plus 4 apples, we have a total of 8 apples. So the 3x plus x plus 4x is 8x. What about the other one? So we have the green there. So what about this? We just did integers today in class. -1, -10, we know that it is -11. You guys have done or looked at your first proper algebra problem. Grouping terms together and putting them all together in one spot as a single simple expression. That is your first algebra problem. Congratulations. You know what a little bit of algebra now is. Okay. All right. One more example and then we move on to your worksheet. So this is example 1. Let's do an example 2. Okay, I'm going to make something up here. Let's have x squared minus 2x plus 3x minus 4. I'm going to make this look scary for you guys, but you're going to realize it's not scary in the least. Okay, the key is identify like terms. First of all, there is a x squared. Is there any other x squared in this expression? Yes, there is. And the answer is the -3x. So here's the beauty of it. It is so simple now. We're going to write the answer. This is one of them. So that is 1x squared. And we are going to go minus 3x squared. So 1 take away 3 is -2. So the answer here is -2x squared. We have grouped the x squares together. Let's group the x together. So we have -2x, positive 3x. So -2. If you add a 3 to it, okay, it is a positive 1. So I can go here, positive 1x. You don't have to write the 1 if the answer is 1, because 1x is the same thing as 1. And then finally, you have this. Oh, sorry. Same ink. Let's use a different ink. Okay. Now, there's only one of this guy. There's no more terms for the 4. So all we do is simply write them because we cannot do anything together. So here we go. This is the algebra problem that you need to do. And I'm going to have a worksheet in the content, and you guys can go ahead and complete that.